validating a contentious discovery made with the agency's Hubble Space Telescope more than 2 decades ago. NASA's James Webb Space Telescope has resolved a puzzle. Hubble revealed evidence of a huge planet orbiting an extremely old star, nearly as old as the universe, in 2003. Only trace amounts of the heavier components that make up planets are present in such stars. This showed that some planet formation happened when our universe was extremely young, and those planets had time to develop and grow enormous inside their primordial disks, even bigger than Jupiter. However, how? This was confusing. Researchers used Webb to examine stars in a nearby galaxy that lacks a lot of heavy metals, similar to the early cosmos, in order to find the answer to this issue. In comparison to young stars in our Milky Way galaxy, they discovered that some of the stars there had planet-forming disks, and that these disks are longer-lived. Study leader Guido De Marchi of the European Space Research and Technology Center in Noordwijk, Netherlands, stated, "With Webb, we have a really strong confirmation of what we saw with Hubble, and we must rethink how we model planet formation and early evolution in the young universe." NGC 346 is a large star cluster in the small Magellanic Cloud, a dwarf galaxy that is one of the Milky Way's closest neighbors. This image was captured by the James Webb Space Telescope. The NGC 346 cluster provides a close-by proxy for examining star settings with comparable circumstances in the early, distant universe because of its relative dearth of elements heavier than hydrogen and helium. The locations of the 10 stars studied in this study are shown by 10 tiny yellow circles superimposed on the image. Only a small number of heavier elements, including carbon and iron, were produced in the early cosmos by supernova explosions. The majority of stars were formed from hydrogen and helium. The Webb study's co-investigator, Elena Sabi, chief scientist for Gemini Observatory at the National Science Foundation's Noir Lab in Tucson, stated, "Current models predict that with so few heavier elements, the disks around stars have a short lifetime. So short, in fact, that planets cannot grow big." But Hubble did see those planets, so what if the models were not correct and disks could live longer? Webb was directed on the Small Magellanic Cloud, a dwarf galaxy that is one of the Milky Way's closest neighbors, in order to test this theory. They specifically looked at NGC 346, a huge star-forming cluster with a relative deficiency of heavy elements. In order to investigate star settings with comparable circumstances in the early, distant universe, the cluster provided a close-by proxy. Many stars in NGC 346 that were between 20 and 30 million years old appeared to still have planet-forming disks surrounding them, according to mid-2000s Hubble images. The prevalent wisdom that such disks will vanish after 2 or 3 million years was contradicted by this. According to De Marchi, the Hubble findings were controversial, going against both the current models and empirical evidence in our galaxy. This was interesting, but we could not really tell if we were seeing real accretion and disks or just some artificial effects, without a way to get spectra of those stars. The first ever spectra of developing sun-like stars and their surrounding environs in a nearby galaxy are now available to scientists because to Webb's sensitivity and resolution. Even at the relatively old age of 20 or 30 million years, we see that these stars are indeed surrounded by disks and are still in the process of gobbling material, De Marchi added. Additionally, compared to nearby star-forming areas in our own galaxy, planets have more time to form and flourish around these stars. This result contradicts earlier theoretical predictions that the star would rapidly blow away the disk when the atmosphere surrounding it contained very few heavy elements. The disk would therefore have an extremely short lifespan, less than 1 million years. However, how can planets develop if a disk is not present around the star long enough for the dust grains to adhere to one another and for pebbles to form and form the planet's core? According to the researchers, planet-forming disks may continue to exist in settings deficient in heavier elements through two different methods, or possibly a combination of them. The star first applies radiation pressure in order to blow away the disk. Elements heavier than hydrogen and helium would need to be present in the gas for this pressure to work. However, only around 10% of the heavier elements found in our sun's chemical makeup are found in the huge star cluster NGC 346. Maybe a star in this cluster just takes longer to spread its disk. The second idea is that a sun-like star would need to begin from a larger cloud of gas in order to form when there are few heavy elements. A larger disk will result from a larger gas cloud. Therefore, even if the radiation pressure were acting in the same manner, it would take longer to blow the disk away since it has more mass. The accretion lasts longer when there is more matter surrounding the stars, Sabi stated. It takes 10 times longer for the disk to vanish. This affects how a planet is formed and what kind of system architecture can be used in these various settings. This is really thrilling. The paper by the scientific team was published in the Astrophysical Journal on December 16th. The best space scientific observatory in the world is the James Webb Space Telescope. Webb is investigating the enigmatic architecture and origins of our cosmos and our place in it, as well as uncovering mysteries in our solar system and peering beyond to other worlds orbiting other stars. NASA oversees the Global Webb program in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA. After more than 30 years of operation, the Hubble Space Telescope is still producing groundbreaking findings that influence our basic knowledge of the cosmos. NASA and the European Space Agency, ESA, collaborated internationally on the Hubble project. The telescope and mission operations are operated by NASA's Goddard Space Flight Center in Greenbelt. Mission operations at Goddard are also supported by Denver-based Lockheed Martin Space. NASA's Hubble science operations are carried out by the Association of Universities for Research in Astronomy's Space Telescope Science Institute in Baltimore.